This is the final version of my binary button echo project. The hardware components are made up of input and output sides. On the input side, a dip switch is wired to ground and Arduino pins set to input an internal pull-up on a breadboard, which allows the switches to send their high-low signals to the output side, which is the serial monitor on the computer, and also the bar graph on the T. Moreland PCB that is encapsulated in a 3D printed case. In conjunction with software conventions, the serial monitor and bar graph are able to read, output, and represent the dip switch signals in binary. To achieve this working final product, both input and output sides of the project had to be properly assembled and well designed for aesthetic appeal. To start, I assembled the input side of the project, which consists of the breadboard, the dip switch, and the wires, to the input Arduino pins. To assemble the output side, I soldered the components of the T. Moreland bar graph onto the PCB itself. I also designed a case for the PCB to give it more of a formal look. The case did not come out as fully expected, but with some slight modifications after the fact, it was still usable for the PCB. One of the most important components of this project is the 595 shift register. This IC is what allows the 5 Arduino pins being used to turn into 8 output pins on the register itself. It does this using 3 main inputs: the data pin, the clock pin, and the latch pin. How it works is that when a button is high, the data pin turns on and a clock signal from the clock pin pushes the information received from the data pin through the shift register and into the bar graph. During this process, the latch pin shuts down so that there are no floating lights on the bar graph while the signal transfers. It also uses the shift out function on the software side of the project to tell the IC to do this. The purpose of the software used in this project is to define all the pins used on the Arduino, either separately or as an array, set them to output input high or low, and run them in a loop that tells the Arduino what to actually do with them. In this case, that would be to use if statements and a binary sum variable to tell the Arduino how to select and add binary digits that will be displayed on the serial monitor using the serial print line function for the serial monitor and the shift out function for the bar graph. And that is how this project, the binary button echo, works. Thanks for watching.